Sure. Thank you, Brito. So, hello everyone, and ISC Square Bangalore chapter members. Good evening. Also, good morning to our speaker and attendees who are connecting from Brazil today. We have a guest speaker from Brazil, Filipi. Myself, Krishna Pandey. I'm current president of ISC Square Bangalore chapter, and I would like to welcome you all to our first of the 4 webinar series on next generation technologies and cybersecurity, which would be focused on artificial intelligence, 5G, and IoT. For the year 2021-2022 in sponsorship with GE Healthcare India. This year has been challenging for most of us, and me and all other board members miss meeting all of our chapter members and participants in person. As I was discussing with Girish, the local meetups were a great occasion to experience the passion and energy of all the budding security professionals we used to meet and guide them. At the same time, it provided us an opportunity to network with also senior members of the community. We have a lot of C-level executives in our chapter as well. It also embodied human touch, personal connect, and raw feedback for us to kind of imbibe them in our ongoing journey. With that, I would like to move to the next slide and just a second. So I would like to thank GE Healthcare India and especially Mr. Anand Tapikar for sponsoring this webinar series. The board looks forward to continued collaboration with GE Healthcare India towards ongoing cybersecurity education and awareness. And I would also like to thank all our present board members who really worked hard to make this event possible. As all of you know, to make an event possible, it requires a lot of effort. So please welcome Brito, Siddhan, who is our secretary of the ISC Bangalore chapter, Kamal Sharma, who is VP External Affairs, Silpa Iyer, who is Director of Membership, Devin Durgapal, who is a moderator for today's event and also our treasurer, Prasanna Venkatesh, who is our Director of Communication, and Prasanna Venkatesh, who is the Director of our Learning, and Chandrasekharan Lakshmanan, who is the Director of Communications. This is the agenda for today's and tomorrow event. We will have a welcome keynote from Girish Raghavan. Rest of the sessions will be introduced by Devendra, who is the moderator of our session today. So without further ado, let me hand it over to Mr. Girish, VP Engineering for GE Healthcare India, to present the keynote speech. Over to you, Mr. Girish.
So thank you, Krishna, for the introduction. So let me share my screen. So can you see my screen, Krishna?
Not yet.
Okay now?
And it's not visible yet.
I'll just put it once more. Okay. Is it visible now?
It's loading. Yeah, it's loading. Yes.
Let's come.
Okay.
Yes. Thank you. Thank you, Doctor. Thank you, Mr. Girish.
Yeah. So firstly, thank you all for joining this session today and for the opportunity to present to this I would say privileged group. So thanks for the opportunity. So today, in the next 10 minutes, I would like to walk you through what we are seeing in the healthcare industry, specifically the challenges we are facing in healthcare and how technology is going to play a very important role in the days ahead, right? So as Krishna was alluding to, right, the last 1.5 to 2 years has been, I would say, very traumatic for most of us, either through our friends or family members who have gone through this COVID crisis. I also think in the last couple of years, the awareness of the healthcare ecosystem among the general public has gone up tremendously, right? That is something we are seeing significantly, where even family members talk about the ecosystem, the stress in the systems, and so on and so forth. So I would like to start with talking about some of the key themes we are seeing in the healthcare market today, and some of the specific challenges we are seeing and how technology can play a big role. So from a key theme standpoint, there are 4 big themes we are seeing. One is we are seeing a huge challenge with capacity, right? So every year we have around 160 million people who move from poverty to middle class across the world, right? And with that, their propensity to pay is also going up substantially. But unfortunately, the healthcare systems are not so elastic enough where they can expand so fast in a very short period of time, right? So today, the healthcare system is really struggling with capacity, and we have seen this like anything during the COVID crisis, right? Oxygen beds and ICUs and CT scans not being available. You take a report, it takes what used to be 1 day to get a PT RT-PCR, it takes 4 days, 5 days to get a RT-PCR report, right? So there's the issue in capacity for sure. The second challenge we're seeing is on productivity and cost, right? So it is said that around 20% of the healthcare spend in OECD countries are waste. So when we say waste, this could be either an over-diagnosis or an over-treatment, right? So sometimes you have a CT scan by MR scan. There's no logic, but you need both, right? It's a doctor's logic of thinking, saying that, okay, I suspect this, let me try that, right? Whatever reason. You have also seen examples where we have, no, we go to a hospital, you have 5 CT scanners, 3 are very busy, 2 are just idle, right? It's just that somebody didn't schedule it properly. We also seen cases where a doctor would come and wait for an hour. He's supposed to be 10 patients, he meets only 7, and the hospital have to pay the consultant for 10 patients of. So end of the day, there's so much of waste in the hospital system, right? It's a lot of money over here. Third is that there's a significant fatigue among the healthcare professionals today. So if you go back and see 10 years back or 8 years back, right, a typical radiologist would probably go through some 10 X-rays in a day or 15 X-rays in a day. Today it is hundreds, right? So this guy gets into his office in a dark room at morning 8 o'clock, and he keeps on seeing CT scan after CT scan, high targets. You're supposed to complete by 8 o'clock in the day. It goes 100, 120, 150. It's significant burnouts happening in the industry. And lastly, it is about medical errors, right? So it is said that the third largest cause of death in the US is medical errors, right? In 2012, there was a study done which showed that 9.5% of deaths in the US is because of medical errors, right? So after cardiovascular and cancer, this is the third largest cause of death. And that could be for multiple reasons, right? It's very fragmented, and this is all known, recorded details, not even things which are unknown, right? So it's a big issue in terms of medical errors. So these are the, if you look at holistically in the healthcare market today, these are the 4 big problems around which most companies are behind. Not only GE Healthcare, most companies are behind these 4 problems, right? Now, what is the challenge we are seeing in healthcare specifically, right? So obviously, COVID has dramatically changed the landscape of healthcare significantly, right? So social distancing, I'm sure you know about it. Resource optimization, I just spoke about it a minute back. But I want to highlight 2 important aspects: the distributed points of care and virtualization of care, right? What I mean by that is that traditionally, right, in 2019, your hospital interaction starts when you enter the hospital. So for example, Manipal Hospital, right? You enter the hospital and then you're in the hospital and you finish your CT scan, X-ray, MR, meet the doctor, go to the pharma, get medicine, exit hospital, and you're done, right? Your transaction stops there. That is changed significantly in the post-COVID world, right? We are seeing what we call distributed points of care, where the walls of the hospitals are broken. In the world ahead, the days ahead, you're going to see that there could be one doctor in a Manipal or in a Apollo sitting there and monitoring hundreds of patients sitting at home. All right, it could be elders sitting at home through which, so you will have Apple Watch and all the wearable devices through which you can monitor SpO2s and ECG devices. You could have multiple wearable devices through which the data would be sent over 5G to the hospital, and there could be command centers through which you can monitor every patient. You'll get alerts coming in saying that this patient has gone beyond that threshold, and you'd act on it very fast, right? A lot of things you're going to see significant amount of innovation around the space of home monitoring, remote patient monitoring, and so on and so forth. The other thing which I want to highlight is also the virtual visits. It's very different. In 2019, if you go and tell a friend, right, or a doctor that I want to do a video call with you to talk to you about my fever, for example, right, it would be seen as arrogance. Right, that is how it is, right? In today's world, that is the norm. It is said that in 2022 onwards, 35% of the patients, okay, would be preferring a virtual connect with the doctor as against a physical connect. 35%. This is something you would have never heard of, right? So this whole space is changing dramatically. With this comes virtual visits. You will have a doctor sitting remotely and seeing scans, right? So as you can understand, right? If you look at this page, you're going to see a lot of uptake on cloud. A lot of things are moving to the cloud as we speak across the industry today, because that is how you will be able to enable virtual visits, remote radiology reading, and so on and so forth, right? You're also going to see a lot of work happening on artificial intelligence data science, and it is indeed happening. It is nothing new. I think healthcare has been a pioneer in this space, especially to reduce the medical errors, right? So just imagine, the same example I told you, right? A guy goes in the morning, 8 o'clock, he logs in, he goes through hundreds of CT scans, right? And then he stops by 8 o'clock in the night when he's very tired. Just imagine that today we have solutions today in the industry where it will automatically look at all the reports you have and bubble up the ones which are significantly impactful. Right? And the system will be able to go and put a circle and show, okay, look, maybe this lung looks like a lesion. Maybe you should look at it in detail. So the whole space of data science and AI is actually helping to assist technologists to make good decisions. In the process, reduce the probability of errors and also make his life much more simpler, right? So this is a space you're going to see all these AIs and clouds, and cybersecurity is again big thing. If you go back and ask any of the CEOs in the world, including healthcare, large hospitals, they're significantly worried about data privacy, cybersecurity, right? They're worried about data theft, right? A lot of things are something which people are concerned about, right? So this is a high level view of how the market is evolving and how healthcare is getting into a major transformation as we speak. The second thing I want to highlight is about just one specific thing what GE is working on, right? I just want to talk about this. I think there are a lot of things which are very phenomenal, but this one thing is significant. See, today, if you look at a machine and an operator, right? The fundamental philosophy is that the machine is dumb and the operator is smart, right? The operator would tell the machine, okay, scan, it will scan. The operator would say, okay, do a lung scan, it will do a lung scan, right? So it is a very, very transactional basis, right? So the system is dumb, the operator is intelligent. In the days ahead, if you look at what we are working on is to make the system smart, and we don't care about the competence of the operator, because that is the only way we can remove the variation coming from operator to operator. So the future, and in fact, as we speak, it is still happening. These systems have parts of it where the system is smart enough to know the system could just raise its hand and say, look, I think the patient on the table is supposed to be having a lung scan. You're doing an abdomen scan. Okay, the system can go back and check at the EMR and see that the doctor has prescribed a abdomen scan and this guy is doing a lung scan, for example, right? Or after the scan is complete, the system can go and see and tell that it is blurred. Maybe it needs a rerun, right? So you will see as we go forward, the system is getting more and more intelligent and smarter. Okay, again, another example is that no, the patient is moving quite a lot. Okay, doing the scan, the system can go back and say, look, the patient is moving too much. Maybe you should put a wrap around the patient so that he doesn't move when for the scan quality to be better. So I can talk of a lot of such examples where the system is trying to become more and more smarter and intelligent so that the operator variability is getting reduced. And this is precisely what you're seeing here. This is exactly what GE is doing today, right? Trying to make the system smarter. And how do you make it smarter? By having applications which are extremely intelligent. And how do you build applications which are intelligent? We need a lot of developer services, which we have. We have got a lot of data. Data is very, very crucial to help us to get to this point. So the whole space of artificial intelligence, data science, and so on and so forth plays a very significant role here. And question is why G, right? What makes G special? What distinguishes us from most of the companies which we have in the market today? Firstly, we have perhaps one of the largest installed bases in the world, right? G has more than 4 million units, imaging as well as mobile diagnostic devices and monitoring devices in 160 countries. So there's a huge number of installed base what we have. And we actually generate a lot of data. Every year we have close to 2 billion records getting generated from GE system, 2 billion plus records, which are generated from GE systems. And as we speak, right, every minute, there are 16,000 CT scans, so 60,000 scans or images getting generated from GE devices. So I these are big data, right? Phenomenal number of data, which is very diverse, cutting across multiple countries, multiple demographics, which are going to help us get to the kind of solutions what we have in mind. So I would like to conclude saying that healthcare is definitely a very defining space. Today, I would say we are at the beginning of a transformation. The healthcare 10 years from now will be very different from the healthcare of 2020, significantly different. And we are just at the start of it. All the whatever modern technologies we have, all technologists like you will have a very important role to play in this transformation. So thanks for the opportunity. And with this, I would like to pass it on to Anand for the next session.
Thanks, Girish, for having this session and providing the insight on the healthcare systems and their challenges and also their innovation happening and looking forward towards the healthcare system. Thank you again. And our next speaker is Anand Tapikar from GE Healthcare, and he is a director of cybersecurity at GE Healthcare, and he will be covering the session on changing attack vectors of the Kubernetes infrastructure platform. Over to you, Anand.
Thank you. I'll just share my screen. Let me know, start seeing my screen.
Yes, Anand.
Can you see?
Yes.
Okay. So good evening, everyone. Today I'm going to present on changing attack vectors of Kubernetes infrastructure. This session, I like to keep it very technical and short. So before that, I just want to give that is all the information mentioned in the presentation is based on my personal research and understanding and experience. No inference can be drawn to my organization. Safe harbor statement. Now coming to the Kubernetes. So I'd like to start with a brief background about the Kubernetes. So why this Kubernetes suddenly come into our application landscape? What is the need? Till now we were working fine without the Kubernetes. We were having a servers, applications, everything was running. And why suddenly Kubernetes is taken so precedence that everybody start talking about it? So the left hand side, what you see, the first thing what we have to see is the why this need has arrived. The first thing which comes into mind is that microservices architectures now getting a lot of traction. Now people want to write a very small agile services which can be expanded by itself. So microservices itself has a lot of ways, lot of methodology, how it should be developed, how services can be divided. And in this microservices architecture, containers kind of technology fits very well. So that's why we see a rise of a containerization adoption. Containerization also provide a convenience to the developer that they can actually don't need to worry about the environmental variables, variation in the environment, etc. So there is a lot of adoptions that are happening in the Docker and many other container technologies. Now, when there's a lot of technologies, a lot of containers has come into the data center or in the cloud, then there is a need of a management system to manage these kind of containers. Because there is automation, we need to really deploy a lot of containers, we need to manage their resources, we need to manage their scalability, we need to manage their visibility, all those are security, etc. There are so many things goes when there are so many containers around. So now to manage all these things, Kubernetes kind of platform coming into the picture. So Kubernetes is generally denoted by K8s. So that's what I mentioned there. So why K8s? So there are a lot of such Kubernetes equivalent platform has come in last couple of years. Like what we say, the Cloud Foundry has come, OpenShift has come, Mesos, Cloudify, Docker Swarm. There are many other platform has come. But as you see in the graph which is listed on the right hand side, Kubernetes has taken a precedence and it has become most popular such kind of system, container management system. And why this has become so popular? If I go into detail, because it's backed by the very strong organization. It was developed by the Google. It is actually backed by the CNCF, and it has a ecosystem developed. That means there are many sub softwares, many subsystems which have been developed, which are supporting this kind of development and convenience for the developers and deployment persons, DevOps guys. So that's why Kubernetes become a very important, and that's why we are talking about it today. And this is a platform for many other technology which we are going to talk in the other sessions. So I wanted to describe what was the earlier and what has changed. Container has changed into our data center. As you see in the left hand side image, you can see there will be some infrastructure. That means there will be server, host, and there's a host operating system. On top of it, there will be hypervisor, VMware or something we will install. Then there will be multiple small guest OS VMs will be there. And on top of it, we'll install the application. When we move to the container kind of world, this whole tower has got reduced. So there is no more guest operating systems. So basically, containers runs as a process in the Linux operating system. So ultimately, this whole process of having a host OS, then on top of it guest OS. So if I tell you that one VM image generally consists of 4 to 5 GBs or even more sometimes. So that kind of scalability and the basically there was a because it's so big image, so deploying such image takes a lot of time. So there was a lot of issues, but container has solved that particular problem. So what are the positive signs? What we saw is it is a self-contained containers are a small footprint than the VM, and it's a faster provisioning because it's very small in the MBs basically. The effective solution for the microservices. So microservices guys loved this and they wanted it. Now what has happened from the security perspective? What issue came is the kernel is actually shared now. Earlier, we can see a guest OS, there is a guest kernel, and that's a very different and isolation we can see clearly. But here is a very less isolation now. And there are a lot of management issue because there are so many sharing of resources, so many containers, which one is belongs to which application, how do you name them, how do you deploy them, how do you really monitor them, how the resource can be allocated. Those issues came. So what I'm going to do, I'll just share you some of the Kubernetes pattern, how they manage this architecture. But before that, let's go to what is Kubernetes itself. So Kubernetes is also one of the application. So manage the containers. So what it does, though it's also called the platform, but it's also an application. What it does, it first you have to install OS and then you install the Kubernetes. And what Kubernetes will do, it enables you to manage those containers and deploy those containers which you will use for your processes or your applications. So some of the components like to cover. I will not go to the full list. As you see in the top block of this Kubernetes, it's a Kubernetes master, which is a controller, you can say, which is actually controlling the whole Kubernetes cluster. There could be one or many Kubernetes clusters, but here we are showing the one Kubernetes clusters, which is running on a 4 nodes. Node is nothing like your hardware or VM, whatever you have existing VM. So on top of it, you are actually installing a some kind of software and making it seamless that okay for the other application developer to come with their own microservices. So like there is some database, you can see the database will contain all those required resources for the Kubernetes. There are some scheduler which will schedule the jobs within the Kubernetes. Controllers are there which will use to control those pods running and nodes running there. So there are a lot of such small processes and a lot of services has been designed to make the Kubernetes work and make the container architecture more and more deployable, production ready. So I'll go to the container architectures. So as you see from the left, how the evolution of the application architecture has happened. So again, I'm showing that the server world where the database was there, single database or multiple database, again, it depends upon the load balancers installed. I'm just showing single database. Then there will be a multiple servers. Some may be running the API processes, some may be running the web processes. Then what has happened when the second generation container thing came, the things become little bit simpler, but like as I explained that the processes got smaller, footprint got smaller. Now it is more manageable, more effective utilization of resources. But now what with the Kubernetes, not even the containers are properly managed, but now we have a proper architecture where the future applications, not just one, but many applications can be deployed into one or many other clusters. So one of the examples has been shown into the right hand side top, where the 3 clusters or 3 or more clusters have been shown, and you have a multiple VMs below there. You can group those VMs and install those clusters, and those applications can come into the multiple clusters. So you can have a one or more application per cluster, or you can choose how many VMs will be part of that particular cluster. We will be able to add more VMs if you have tomorrow you get more resource requirement. So those all the flexibilities are available for the deployment managers as well as the application developers. The below right hand side is shown is that technical view of 3 nodes and how their processes of networking within the Kubernetes are actually communicating. So it's a very complex networking which they have designed within the Kubernetes, which actually is like a small data center kind of environment they have designed, which communicates such a way that the application guys, it's a seamless to the application guys, but even for the networking and as well as the deployment persons, it is very easy to manage those networks within those within the Kubernetes and configure them and make sure that the A application traffic remains isolated from the B application. So there are multiple ways has been designed in the Kubernetes platform. So what are the security concerns in this area? So there are multiple security concerns. So what I would like to put in a very simplicity that there are many threats, external and internal threats comes. Depends where the Kubernetes is installed also. Some people install it on the cloud, some people install it on-premise, some people install it on edge. So it depends where it is installed, and then the external and internal threat comes. But as per if you go into details of a Kubernetes, it is a complex system because there are a lot of configuration you need to do, and there could be possibility of human error also if you do something wrong configuration. So and somebody does it wrong, then how do the visibility comes to the security guys, because security guys generally monitor at the parameter level or at the node level. So for them, this traffic is not visible, what is going on within the Kubernetes. So for that, to get them visibility, there are some extra additional efforts are required. There are network security issues. As I explained, the Kubernetes contains a lot of smaller network within the itself. So there could be some issues in the networking configuration because every network has a separate different ID and it has to be communicate with the other network. So all these network security issues, what we see in the data center environment, that can come inside the application also. There are configuration security issues. As I said, there is configuration, resource configuration, credential configurations, who will access to whom. There are some namespaces needs to be defined. So there are a lot of configuration issues can also come in. If somebody makes a mistake there, then the data which need not to be shared with the other application or other processes that can be shared very easily within the Kubernetes. And security guys generally will not see this kind of breach. There are host security issues because it's running on a host platform running by Linux. There could be some host security issue. The container security issue, like we know, containers are having a lot of vulnerability. Every day there is a new vulnerability comes in the containers, and those containers needs to be updated. Their new container needs to be deployed. Newer versions always come in. The containers providers provide a lot of new versions. So those things come in. Plus, there are many normal issues what we see in the normal world like API, multi-tenancy, data security, credential security, vulnerability management, and operational issue that are also there within the Kubernetes environment itself. I'm going to the security architecture. So what happens when the Kubernetes actually gets installed? What are the things we need to remember? So what I did here, there are 2 nodes which I shown here below that. So the 2 nodes, there were some pods are running. Pods was nothing but you can think about where your services are running. So basically, you can have a load balancer, and as I explained in the Kubernetes, that load balancer communicate with the API gateway, and the API gateway will provide access to the applications and the devices to communicate to these applications which installed on the pods. So what is there? So first we have to think from the left, like how the CI/CD pipeline is going to be for deployment, these kind of Kubernetes. So there, the important thing which I wanted to say, like the container signing and the verification has to be built in within the Kubernetes. So from where the containers are coming in, who is verifying it, what is the trust level of those containers. That verification needs to happen because there will be so many containers. So it may possible that we lose the track of that who is deploying and from where they are getting deployed. Then the node itself, the node requires us a lot of security like in a normal node we do. So we need to have a lot of private subnet defined which node needs to communicate with which with node. Host security needs to be defined. There are SE Linux and other tools are available. Then at the Kubernetes level, namespaces needs to be defined. Logging needs to be enabled. So all those are the nodes issues are taken at the node level. Then at the Kubernetes level, Kubernetes needs Kubernetes itself functions, but it requires some additional services like IDAM, Identity and Access Management. So every service needs to have identity, and it has to communicate with the others other services with those identity. So for that, service mesh kind of platforms has come. Credential management separate platform has come. Logging. So this is an ecosystem I was talking about. Once you integrate the ecosystem with this Kubernetes, then this Kubernetes becomes very powerful and it starts communicating through the API. And then the API level, the calls comes and that get authenticated, and then it's forward below. So that's how the architecture looks like. And every app or device which is communicate with the Kubernetes that gets authenticated directly at the API level, and then finally the services render their own services for these things. Other than that, the horizontals which were there in the earlier data center age, vulnerability management, resource monitoring, identity management, security monitoring, they all get repurposed, but they all are relevant, and they have to monitor the Kubernetes clusters the same way as they monitor the data center and the threat intelligence as we used to do. And there is a specific threat intelligence for the Kubernetes platform as well. So there are some 2 slides that I want to cover on the security issues. So in the interest of time, I just given some links. So basically use the namespaces, restrict the Linux capabilities as much as you can, enable the SE Linux, configure the CG group for the effective resource utilizations, use a minimal host OS. Don't unnecessarily install the services which are packages which we don't require it. Update system patches, though it's tedious task, but it has to be done because that's how we can say from the vulnerability. Run CIS benchmark for the security and the security test. And the last slide is the basic. There is some tools are there. There are a lot of tools which go to the CNCF site. There are a lot of tools are available. I just picked few. The network policies are there. Istio is there. Service mesh, which ensure the service to service communication is remain encrypted. There's a Graphia tool, which is the auditing. There's a Claire tool for the vulnerability management, and there's a Kubernetes CIS benchmark. So with this, I like to conclude, and I can take a few questions.
Thank you, Anand, for this wonderful session on the Kubernetes. So we have 2 questions, mainly on the healthcare system. The first one is, how will you take care of errors introduced by the applications of AI in the healthcare? Like example, like biases and all.
Girish, you want to take?
Yeah. So can you hear me?
Yeah.
Yeah.
So actually, so if you look at the whole space of regulatory world has completely changed in the last few years, right? See, today, if you look at when we apply AI or deep learning kind of methodologies for, so we go through a lot of data analysis. The regulatory world has come with their own guidelines on how to do it. Okay, so they have gone through a lot of research and they come to guidelines. We verify and validate based upon those guidelines, and in most of these applications goes through FDA or European approvals, and then it goes to the market. So there are checks and balances to do it. It's mostly based on data, just like the way we do vaccines, for example, right? It is statistics, it is data based on the guidelines by both the European and the US regulatory agencies.
Thanks, Girish. The second question is also into the regulators. So how are the regulators looking at the products involving AI/ML in the emerging market?
So actually, in the emerging market, the bar is not so high, and most of these emerging market regulators are looking upon the FDAs and the likes, right? So if you look at in some of these emerging markets, the fundamental expectation is that, okay, do you have CE marking, right, or do you have the FDA approval? If you have both these things, then that is what they do it. If you look at countries like India, we are still evolving the regulatory requirements around this space. So until we have a very formidable, rigid framework in place, we'll continue to bank on the FDAs and the CE markings what we have in other countries. So that is how the emerging market is tackling this kind of requirements.
Yeah, thanks, Girish.
We have Rakesh online. So Rakesh, I don't know if you want to add anything, Rakesh, additional to what I mentioned. Okay, I think it's on mute. Yeah, that's it.
Yeah. Thanks, Girish. Thanks, Anand, for this wonderful session on Kubernetes. And thank you again.
Thank you.
So our next session is from the speaker, Filipi Pires, the Principal Security Engineer and Security Researcher at JUP Innovation. So he will be talking about the new mindset about cybersecurity using 5G. Welcome, Filipi, and mic is yours.
Okay. Hello, everyone. Can you hear me?
Yeah.
Yes. Nice,
yes.
Nice. Let me share my screen here with you. Just a second, please. And let's start here. Let me share my screen here. Okay. Can you see my screen? Let me share here. Okay.
Yeah, you can see your screen.
Mm-hmm. Perfect. Okay, so today we're gonna talk about the trust or not trust. Actually, my idea here today is to bring you some thoughts. Actually, that's my idea here to you, right? So this is my contact on social media. So if you'd like to send me a message or questions, so I'm totally available to talk to you. My name is Filipi Pires. I'm talking from Brazil. By the way, here in Brazil is at 9 o'clock a.m. It's the morning, right? So I am sharing many contents on the Twitter, on GitHub, LinkedIn. So again, here my webpage with some talks that I am made in some key security events. And again, if you'd like to send me some questions or even sharing your knowledge with me, I really appreciate, right? So I'm security research and security advocate at Sup Innovations here in Brazil. This company is responsible to provide, some developer service actually to some companies. And create, of course, here in this case, some open source projects. All those projects, open source, are in my GitHub. I am advocate from this awesome project. It's Hacking Not a Crime, because in this project, the idea is to spread the information to the community. That's hacking. It's really not a crime. It's a mindset, a creative mind, right? So when you see some software or something, you can use your creative mind, right? So this is the main point here in this project. I'm a part of the staff team of the DEFCON Group São Paulo here in Brazil, and I'm security research and structure from Hacker Security. So I have here, this company, it's a Brazilian company, and it's responsible to give some trainings with offensive security and offensive security in Portuguese language, of course. And I am structured and writer and reviewer from these magazines here, not here, but in Poland, actually in Europe, and because I lived in Poland in 2019, and I am structured there, right? So this is our agenda today. First of all, I'd like to just to talk about what is threat, that to put everyone in the same page. After that, I would like to bring you some AppG is safe. And I would like to ask you, have you heard of at least privilege? I'd like to bring some brainstorming. Let's think together. And now what can I do, right? In the end, security landscapes report, right? So first of all, what is threat? It's very simple definitions, right? It's not my definitions, the definition based on this ISO, right? Because I think it's very interesting because we're gonna talk about the 5G, right? Okay, it's a new technology when you talk about the access, but what is exactly threat? What should be our concerns about that, right? So threat, it's defined as a potential cause of the incident, right? So the potential cause may cause harms to the system and organization. That's my point here. So it means a software attack, or maybe a theft of intellectual property, if you are a manufacturer, for example, or if you work with any industry, probably you have some intellectual property, so you need to pay attention about that, right? And identity theft, it's another example about threats. Sabotage, it's another example, like, you know, some message on Twitter, for example, some attacker can use against your company or something like that, right? And information distorted are example of information threat. It means in the end of the days, all those things is related to a software, right? Because you need to produce a code, and after that you can produce this software or app. You know, it's depending, of course, it will be compiled this software or not. But in the end of the day, you have a code, right? Okay, so 5G is safe. Probably you know about what the best or what the difference between a 5G and 4G. It's not my idea to explain about that to you, but about the concerns I think that we need to have. So another speaker explain more about that. There's some concerns about the security, but my idea here is to explain about of course, you have more access to the internet or the connections to the network, to the environment, but you need to have this attention about that, right? So the first of all is decentralized security, because you have many points of contact, right? So if you are many times you don't have access to put in the same network inside. So of course, if you have the 5G dynamic, the way of you can connect them, it's more fast, and of course, but you have many points of contact. It's very important, because to be completely secured, not to be completed, but this needs to be monitored. This is my point here, because you have many points around the company, around the industry. You have the IoT inside the company, right? You can put some, new technologies or new products, and of course, you can imagine different points, different sensors you need to apply. So you have the decentralized security. So this is one of these concerns. Another, it's more bandwidth with strength current security monitoring. Again, pay attention to these words, monitoring. We need to look into the monitoring. This is my point here. While existing networks are limited in speed and capacity, it's clear, right? So this has helped provide monitor security in real time, because, the attackers happen all the time and the threats are changing all the time. So the benefits of the expanded 5G network might hurt a cybersecurity, of course, right? So here, my point here, the volume will challenge the security teams to create a new method for stopping threat, because again, if you apply this 5G solutions in some industry, it's not the common environment that you have. You need probably the attacker. The attackers can looking more deeply about this kind of structure, right? So that's my point here. Another point, it's many IoT devices are manufactured with a leak of security. Here is, I think, I don't know if you agree with me, but no worries if you don't agree, right? But again, the technology are growing. It's completely acceptable, and we deserve that, right? But the point is here. The technology is growing, but the cyber criminals are growing too. So when you have some manufacturers or some IoTs putting inside of your company, and of course you have the gain of the technology, you have the access to the 5G. But the point is, many of these products are created by some companies, and many times the security access is I will use this word, a poor security, like authentications or authorization process, the bad passwords. So that's my point here. So I think today it wrote here, smart TVs, door locks, refrigerators, speakers, and even minor device like thermometers for a fishing tank can be network weakness. So sometimes our desire to put many different things in our company, but these softwares are connected to the internet. And again, I have 5G open to the internet, and if I open my connections or my environment to the internet, probably I will have a problem in the future with some leaks or exploitation or exposing data, right? So again, here, as I mentioned, lack of encryption early in the connections process, right? So revive devices info that can be used for device-specific IoT target attacks. So if you already heard about the some hackers happen in hospitals and web babysitter cameras, and because the encryptions, the password, it's so bad, it's just a 4 numbers or 6 numbers, so it's easy to break this if you are a contester, if you are a threat actor. That's my point here, right? So some concerns that we need to have, and of course all those systems, all those assets that we have the access inside the companies, right? So we need to read these concerns about the security 5G, because again, you have very fast access, but you have this challenge, right? So let's think about that. This is some guide that I see in this web page in the Ericsson.com. I think it's pretty interesting because you can see some process like this, right? So operation process, deployment, vendor product development process. You can choose what the best, right? Because my idea is not to give you or to tell you what is the best, right? And just suggesting. My idea here is to bring some thoughts, just like this, right? And telecommunication is standardization process, right? So you need to have this security operations procedures, because you need to understand, again, monitoring. Do you remember the word? Monitoring of performance of security functions, like a vulnerability management, because probably some softwares in IoTs, it was legacy, because, it's, of course, nowadays we have many important manufacturers creating some IoTs, but in the past, we don't have, like, we didn't have, right? Response and recovered after the breach, it's very important, because you need to recover, you need to have the fast response if you receive some attack. Deployment, in this case, a solid network design. Again, you need to be a resilience, a good word, right? Configuration of security parameters, hardening, it's another important thing to apply in your environment. Vendor products development process. So here you can choose what the best. So you can, by the way, you can prove. You need to prove actually. And in my my GitHub, you can find many tests that I made in many security sensors. You can use in like some guidance, right? And telecommunications standardization process, security protocols, algorithms, and storage. Like, so it's a good suggestion that I said. Have you heard of a least privilege? So what is the last privilege? It's a good point, because remember, we have the 5G access. We have the very fast access, but how I can protect my company against attackers? So in information security, computer science, or other fields, the principle of least privilege, also known as a principle minimal privilege. It means I just give the access to the main, not a main, but the specifically people, right? So requires that in particular abstraction layer of the computer environment, every module, such as a process and users and a program, and depending of the subject. It means we have many users in your environment. In the past, we give the access just admin IT, the privileged access. But now, as another speaker says during this conversation, is we have many teams around our company. We have a CI/CD team, the responsible to DevOps team, and the database team. So how you can imagine this access? So if you apply this list privilege, maybe you can have some success against the threats, right? Some brainstorms, guys. So inside the threat, who is? I think our speakers, the last speakers, talk about that, because we have today many insiders of our companies, unfortunately, but we have, right? So we need to pay attention, we need to see about that, and need to be some attentions, right? So privileged access in the past is just only admin IT team, right? So now I need to give the access to the C-level access, right? Because, you know, you can imagine you have the C board in a meeting in another country, and they need to access some apps, some applications, web applications in the environment, or they need to have some access, and they need to have the access. Basically, you can block it, but because it's a C-level, you can imagine the shame when they need to present something in some meeting. And today we have the work from home, remote workers, like because of to be accelerate because of the pandemic maybe, but now we have different works from different employees work from home. Cloud assets, it's very common now. It's all those companies are as born in a cloud, right? So what would be the risk of the impact? This is the key in the end of the day. What the real risk if I have some data exposed, right? So, but now how this works in our company. Now we have a developer team, again, access in many different apps. So you need to give the access to those developer guys. And you imagine if you apply this 5G in some area in your company, you need to have the access, but you need to see about the privileged access, right? And the DevOps team, as I mentioned, access on many systems, database teams and cloud teams, leaders of the business units, the tech leads, or the directors, you need to give the access. So take a look at this. Now you need to give the privileged access for everyone, but how you can manage it, right? So let's think together. You can think about the privileged access. Of course, it's traditional categories are under the EMI, right? So identity access management, but EIM involves an anti-recently conventional approach around the users and digital identifier, right? And of course, it is increasing because of the cloud environment. It was growing, right? And you need to manage the user, the password, but you need to think about the privilege list, right? So the minimal access, but you need to give the access. So how you can create that, right? So for these reasons, if you think about the solution, that's a suggestion, right? Again, I'm don't talk about what the best solution, just about the concept, right? So EMI and PAN best practice have evolved to a point where security professionals prioritize security volume of credentials for a privileged accounts, in this case the object, and security access to the privileged data and systems, infrastructures, and applications. It means you can imagine the first challenge that we have in a 5G concern about the centralized network. Do you remember? So you need to, how you can manage it. In my opinion, again, I don't know if it's correct or not, just a suggestion, right? And you need to manage it. You need to look into the access, because the access, in the end of the day, the employee will be access to your environment, and the day of the day, the users will access the data, right? So the data, maybe it's the most valuable information that you have in this case, right? So the dynamic now holds true for all user scenarios and any operation eventually, right? So here I would like to suggest you some another concept like what is zero trust. I think you know about that. Just a suggestion again, it's the idea behind the zero trust is that the enterprise shouldn't trust anything. Again, do you remember about the insider? As I mentioned and another speaker mentioned. So if we have insiders or intruder or inside of our company, you need to see about that, how I can protect my company about these attackers, right? Some principles about the zero trust, just suggest you again, know your infrastructure, know about the users, devices, and services. If you apply some 5G in your in some area of your company, and understand how the architecture works, right? So create a single strong user identity. It means when you apply that, the organization should use a single user directory and create accounts that are linked of two individuals. Create a strong device identity. Each device owned by your organization should be uniquely identifiable in a single directory, device directory. And if you are a manufacturer, you can see about that better than me, about your architecture, about your structure, that you need to apply. In this case, a device identity, because sometimes in this industry, you have one machine in the manufacturer, and many users access this machine. So in this case, create a strong device identity, right? So here, the source of this principles, it's an open source blog post here, some information awesome about that. You can read after this conversations. Another principle is authenticate everywhere, right? So in a zero trust architecture, assume the network is hostile, right? So authentication, all connections. So again, if you have the 5G in your environment, you need to check this, right? So this is my suggestion, right? Know the health of your devices and service. Perfect. Because you need, this is, I think it's one of the most important signals used to gain the confidence in them, right? Focus your monitoring, again, the word monitoring, on devices and services. Give that the devices and services are more exposed to the network attack than in traditional architecture. It is important then comprehensive monitoring for attacks is carried out. It means you need to see all those devices and services and users, right? So 3 words. I mean, again, devices, services, and users, right? And of course, I can add another, like a process, the policy, maybe. Again, set policies according to the value of service and our data. It's very important. Powerful of zero trust architecture is coming from the access policy that you define. So again, decentralized network. So you need to apply something to this challenge, the some 5G consonants. Remember, control access to your services and data. Each request to a server should be authorized against a policy. Perfect. So you need to have this control the access, each one request that you have, or each request that you need, right? So don't trust the network, including the local network. Again, take a look at the intruder, right? In order to remove trust from the network, you need to build trust into devices and services. Choose services designed for a zero trust, just a recommendation, because again, if you have this challenge in 5G, this is a main concern. You need to have the monitoring. So the best way is to see about the monitoring, about the creating a zero trust, including the IAM and PAN solutions, right? So security landscapes report about this environment, right? So I bring you some reports from Trend Micro in 2020, by the way, it's the last year, some exposed related to these manufacturers, right? That's my idea here to explain. So the cyber criminals will home in IoT devices for espionage and extortion. So we have machine learning increasing the environments, or artificial intelligence will be using to listing a connections device, because the companies are growing. As I mentioned, the technology are growing. So of course, we will using this to help our business, but you need to pay attention about that, right? So use a language to recognize an object, identify routers hackings via botnet used as a distributed network, or for domain name servers, like a DNS injection, a kind of attack. Another point is 5G. Again, adopters will grapple with the security implications of moving the software-defined network. So here's another concerns. Vulnerabilities due to the newness of the technology. Yeah, I mentioned about the 5G. You have bad things if you'd like to apply, but you need to be paying attention about that, right? Vulnerable software operations, wider avenue for attacks, and threats related to a confiability, integrity, and availability. So how you can apply some securities or softwares or sensors about that. So remember about this concept. I bring you these concepts and how you can manage this improvement. Like you have a 5G, you can see an adopter of the 5G, but you need to see about the monitoring, the people, the process, how you can apply the security, right? So another is a critical infrastructure will be plugged by more attacks and productions downtime. So many companies suffering DDoS attacks against operational technology, networks, an example, insecure cloud providers as jumping off points for immobilizing productions, right? So again, as you can see, 2020, the last year, you can see some attacks that happened around the world. In 2019, we had the same the same attack, the same, it doesn't change, unfortunately, but because again, in the same way that the technology is growing, the cyber criminal, the techniques are growing too, right? So home office or other remote working setups will redefine a supply chains attack, right? So again, work from home, as I mentioned, right? Cyber criminals will design enterprise attacks using a home in a public network by impersonate employee. One of these most techniques, because usually when the users are at home, the user don't have any concerns about the security stuff or something like that. No, because they are at home. It's made confusion because of course they work from home, but the employee is at home. If the employee goes to the office, it's different, because in the office the employee needs to be attention what their websites they can access, or something like that. But if the employee are at home, make a confusion, right? And yes, and now I finish my presentation. If you have any questions, so I don't know if you have time, but I'm totally available to talk to you. And thank you again for this time, and thank you for having me here.
Thanks, Filipi, for this wonderful thought-provoking session. And we have a couple of questions on this. So very first question here is, not all IoT has enough resources to use stronger ciphers. And so how do we achieve the better security, considering the principle of least privilege is already in place?
Okay, so I don't know if you understand the questions, but let me try explain about the point here is you have today and nowadays we have many different points of access inside of the company. If you apply the 5G technology, depending of your architecture, you need to apply those security, right? So this sensor to gain the access. And of course, when you set the privileged access, you define what is the most important about your data, right? You can set this policy, you can apply that, you can define who is responsible to access this device or these applications or this system. But the point is, you have the technology to help you, but you need to see about the monitoring all those things, because we have many different areas in our companies. So the challenge is how I can see all those movements inside of the company, and how I can guarantee the access to the real access, to the true access. Just if you apply the less privilege, at least privilege, or the least privilege, and you need to apply the identity access management, and in this case, least privilege, it's more related to a PAN, privilege access management. But all those access, in my opinion, again, I don't know if it's correct or not, but in my opinion, all those things is inside of the big concept called zero trust, because of course, zero trust is, maybe it's a culture, because I will access the whatever or some app. And what is the rule for me to access this app? It's a PAN, it's a privileged access. I can set in the least privileged access. So why the user need to access the some databases if the users don't need any services, they don't have any services, anything to access in this database? Why the user need to access this database, right? So that's my suggestion here.
Yeah, thanks. So next question is on how can a 5G improve security for the critical infrastructure and the IoT applications?
Good questions. No, it's a challenge. I think it's not a challenge, it's a big challenge, because if you apply IoT, remember, today and nowadays we have many manufacturers creating some IoTs, right? And the challenge is we need to have a good software, inside of these IoTs. That's the point here, because if you try explore your router or your webcam, your personal webcam, or if you buy some personal webcam to stay home after, actually, but usually when you try explore some IoTs, but personal IoT, it's very simple to explore because they have a bad softwares, a bad password, as I mentioned during this conversation. But if you have some critical infrastructure, you need to see, we need to apply, again, in my opinion, you need to see what is happening in your network. Because, for example, if you see here, this is my, I forgot the name in English, but it's a fund, right? So how can I guarantee the security of these critical stuffs? So I need to see about the network. If I don't have access to this fund, I need to see about the network, how this works. And I need to see the perimeter of this manufacturing, critical infrastructure. So I need to give the limited of the access in this environment, right? So that's my recommendations.
Thank you. The next question is, how real is espionage threat around 5G equipment from certain countries?
Sorry, can you repeat the question, please?
So how real is the espionage threat around 5G equipment from certain countries?
Again, if I understand the question, so how is spread the threats, right? So against,
yeah,
or protect, yes.
Yeah.
Oh, okay, perfect.
Yeah.
Okay,
it's about that. How real is the threat around the 5G equipment from a certain threat?
Yeah. The point is, so I don't know how many countries give the adoption of the 5G, and the point here, of course, you need to understand where is the place you will apply the 5G, because the 5G in the real concept, if you read about that, it's very simple. You give the fast access, So you can imagine. So if you have some, if you buy for some internet cable for you, you have 100 gigabits or 100 megabits, and if you're using for a 5G, let's suppose, okay, if you have a 1 gigabit for access, you will use the 5G because it's more fast, to pass your data or something like that. So in the end of the day, 5G give you more fast access. So because of this, many manufacturers apply this in critical infrastructure. So how we can protect this from the attackers? When you use 5G, you can compare with the 4G, right? So you have the free access usually. You don't apply the some security sensor. So you need to see how this works. What is the router responsible to give the access? You need to see how the systems works, and you need to apply of the best practice of this router. You need to see again about the perimeter. You need to see how this, for example, one of this concept of the threat hunting is if you're using threat hunting based on EOA, indicator of attack. So if you live, for example, in India and you don't have any business with the Brazil, so why your employees needs to be access to the Brazil? Don't need to be access. So you need to protect this. You need to apply the process. So that's my point here. Again, 5G give you the fast access and another things, okay? But the main point is the fast access to the internet. And so how you can see, you need to see about the router, about the connections, you need to understand more about the network, how the packets works, right? So to see about the packets works, you need to see more deeply about your network environment. Remember about the principles of the zero trust, understanding about your infrastructure, right? So you need to see how your infrastructures works in your critical manufacturer and how this works exactly. When you understand about that, you can see where is correct place that you can put the security sensors to protect you.
Okay, thank you. The next question is, there can be a security risk in case of offloading the 5G traffic to the Wi-Fi network. If the Wi-Fi network is on par with the 5G in the security, any comment? I'll repeat the question. So there can be security risk in case of uploading the 5G traffic to the Wi-Fi network. And if the Wi-Fi network is on par with the 5G in security, any comment?
Nice question. Again, so remember, the point is when you have some, for example, many access point in your environment, and you need to see how this works. So you need to set some policies in this environment, and of course all those things managing this environment, like manufacturing environment, or maybe if you are a hospital and some machine responsible for a react or something, or some exam that they need to apply or something, or if you have some control to the access in when you go in the building, for example, you have many points in the company. So if you talk about the 5G security, again, you need to have the attention of all apps that you have in your company. And after that, you can apply this. Again, another suggestion. It's applying about the PAN, the Privileged Access Manager. You need to set in these configurations. It's not because in the past, nowadays you have the VPN, right? The VPN give you the access to inside of the network. So if you explore the users, for example, work from home, you gain the access to the internal environment, right? But if you have the at least privilege, so these users can be accessed just only app they need, or that he needs, right? So that's my point here. So if you apply the 5G, you need to connect this access with your policies. You need to have the good policies in this. And do you remember about as I mentioned during these presentations, process, users, architecture, and services. So one of these keys is about the process, the policy. You need to define this, but how you can define this correctly? You need to understand how this infrastructure works, how this process works, how this environment works, like how the teams works, what kind of access the teams need to have, and the systems, and something like that.
Yeah, thanks, Filipi. There's the last question here. Is SIM cloning issue resolved in 5G? Is SIM cloning issue resolved in 5G? And as the private key embedded into a SIM card, so how the service provider protecting and rotating the keys?
Good questions. Because again, so if you see about the cloud service provider, I don't know if this question is about that, but the cloud service provider, if you see, one of the keys when you have the cloud service provider is the sharing responsibility, right? So if you have some services inside of this cloud service provider, like AWS or Azure or GCP or whatever, all those cloud service providers recommend you to apply some security sensor. Of course, they have some security settings to apply, but the main point here is the cloud service provider recommending some security sensor. So you need to be a pay attention. Of course, for example, let's suppose that you have a car connected to the internet or an infrastructure. It's impossible to install antivirus in a router, or impossible to install the antivirus in a phone. It's totally impossible. So how you can protect this? You need to see how this marketplace works in a cloud service provider. If you are on cloud service provider, if you have the private cloud service provider, not provider, but private cloud, how you can manage it. You need to see, again, you need to set some privileged access. You can have the zero trust. It's a challenge because you need to see all those teams works. You need to have, for example, as a SOC team to see the logs, to see the behavior, because in my opinion, again, just to see the threads inside the environment, you need to see a good monitoring stuffs, right? So that's my key here. You need to see about how all those things works. Like my home here, you know, I have four kids, right? Not kids, four kids. Okay, it's a twins and two teenagers, right? So to help them, I need to understand how this works here in my home. My company, it's the same case. So how this works, I need to understand all those things, all those rules in this case, in my case, in my example, but in your case, is how this works, the teams and something like that.
Yeah, thanks, Filipi, for this Q&A and the insightful session on the 5G. Thank you. So our next.
Yes, my pleasure.
Thank you. Yeah, our next session is from Dr. Saquib. He's a senior vice president at Reliance Jio Infocomm, and he will be providing insight on privacy preserving AI system. Welcome, Dr. Saquib. The floor is yours.
Good evening. Yeah. Can you see my slides?
Yeah.
Okay. Yeah. Good evening once again to all of you, and it has been a pleasure. And I was watching the earlier talk. Very interesting. A lot of information. My talk today is basically on a subject which is, you know, confluence or intersection between security and AI. Okay. Security has been a subject which has been around for quite some time, very mature subject. AI also has been around for some time, although not as mature today as security is. But when we talk about AI today, I will talk about AI in a very special context, very specific context, which is AI in healthcare, and more specifically, AI in healthcare imaging, because I've had some, you know, experience in doing some of these projects, and I will just share my experience with all of you. So AI in healthcare has come a long way last 8 to 10 years, and although it has solved many long-standing problems, but still, you know, we have a lot of concerns about AI today, and that is one reason why it has not been very successful in some countries, okay. Especially, you know, some European countries and perhaps Asian countries as well. And the reason is that, you know, people are very conservative about sharing data. Okay. And AI is all about, you know, training a model, and after having trained a model, you create inference on it. So all these years, last 5 years or so, there's a lot of talk about, you know, lack of access to unbiased and complete data sets. So what we have today, the models today which we use in our experimentations are perhaps, you know, have data which is localized. Okay, local data in terms of geography, in terms of demographic, and so on. That is one issue, and the reason behind it is that people are not very comfortable today to share their medical data, medical and finance data being, you know, the very sensitive data, and that is one reason. Second reason is when we talk about the Western countries, we have very rigorous regulation, and most of you probably are aware of HIPAA and GDPR and such regulations, which are pretty strict in nature. Okay. GDPR Section 17 is one of the most controversial sections in GDPR, and we'll talk about it if time permits. And of course, you know, on a personal customer patient level, we have questions about privacy and security from ethical point of view. Okay. Even if there was no rigorous regulation, we still are, under the umbrella of privacy and security. So we'll talk about all these issues as much as we can. So AI in healthcare is a very multifaceted field. Not that any other field is not multifaceted, but because it touches upon very private and individual data, it makes things a little more complicated. In AI in healthcare, for example, we have patients, hospitals, research institutes, algorithm developers, diagnostic equipment vendors, industry, and lawmakers. It's a mix of stakeholders, and each stakeholder has a divergent motive. Not that they have a negative kind of a motive, but every stakeholder have their own motives and motivation to be in this business. And this whole ecosystem threatens and diminishes the importance of individual privacy. Now, privacy laws are not very mature, or rather not there right now in India. But whenever they come, I'm sure there'll be some kind of a replica of Western laws, and more or less. Okay. So far, this ecosystem is threatening our importance of individual privacy. And what are the attack vectors? Okay, what are the attack vectors we're talking about? Now, there are two entities which are very important in AI infrastructure. One is, of course, a data set, which is the central theme of any AI. Okay. And all the adversaries and attackers and the malicious users try to attack data sets in a way which can be classified under these three types of attack vectors. First one is re-identification attacks. In such attacks, the adversary tries to determine the identity of a user or a patient indirectly by using some other information. For example, using information on dental records and retina records, someone can narrow down the number of patients who are of certain age group, for example. If somebody is above a certain age group, you can narrow it down. You probably will not be able to identify a single individual, but it is possible to narrow down certain individuals based on certain images, orthopedic images, for example, chest images can easily be identified and narrowed down to certain ages and age limits. Then you have another attack vector which is very heavily used today, is data set reconstruction. This is similar to side channel attacks in traditional mainstream security. In this case, the adversary tries to derive the characteristics of any individual or maybe set of individuals based on computations without having access to the data itself. By trying to understand the type of computations going on in a particular memory map, it is possible to find out if there is a particular individual or set of individuals in that data set. Okay, these are called data set reconstruction attacks. And the third attack vector is called the tracing attacks, in which I may not know as an adversary the exact identity of an individual, but I just want to know if that individual is present in this data set. All I need to know is the presence of that individual in a particular data set. So these are called tracing attacks. Now these attacks are becoming very, very commonplace in AI, especially in service provider kind of environment where you have small organizations outsourcing their data to third-party service providers. You have these kind of attacks which are very visible. Then you have attacks on algorithms. So please remember that it's not only the privacy and the security of data which is important. We also have to take care of the security and privacy of the algorithms. Now, compared to algorithms in mainstream cybersecurity or security ecosystem, where most of the algorithms are embedded into an appliance. Okay, most of them, if not all. And it is almost impossible, if not impossible, almost impossible to get access to those algorithms and be able to modify or manipulate them. Now, as opposed to that scenario, in AI, most of the algorithms are not embedded into any appliance. These algorithms are sitting on a server somewhere, or sitting in a mobile phone, smartphone, or maybe some intermediate device. And majority of them are software algorithms, software artifacts. These are not embedded into any appliance as such. So manipulation or attacks on these algorithms are easier as compared to attacks on algorithm which are embedded in appliances. That is one type of attack which is very common. And then the second attack is model inversion attacks. So instead of attacking the model itself or the algorithm itself, which I have no access to, I can derive some information about the data set by reading the memory map or algorithms weights or understanding or following the behavior. So this is another type of attack which allows, obviously these attacks are very sophisticated, and but nevertheless they are threats which are common in AI. So we have talked about attack vectors on data sets, and we are talking about attack vectors on algorithms. Now, the idea is to secure and privatize, or rather make private these artifacts and data sets in an ecosystem which is end-to-end, which has end-to-end security. Okay. Now, some terminology which is used in AI for privacy, for example, and these terms have been around for quite some time, and these are the current best practices used in many smaller organizations. The first one is anonymization, in which you remove all the personally identifiable information or any metadata from the data set. So if I'm talking about retina information or lungs or brain MRI or whatever, I simply remove the person's name and age and demographic information and just process the images directly. And then pseudonymization, which means I don't remove that information. I replace the information by some dummy or synthetic data and then create a separate storage for lookup table. Okay. So both these methods are being used today in many organizations, but there are many problems with this kind of privacy. Taking care of privacy through anonymization and pseudonymization. One is that this can cause a lot of human errors and a lot of errors, and not only human errors, it can also cause indirect side channel kind of attacks. So, for example, I talked about reconstruction attacks are very possible, even though you have anonymized data, and we'll see in a later slide how that is possible. So very weak kind of security in privacy, but nevertheless that is being used today in many organizations to take care of some issues. However, now when we use the term secure AI and privacy preserving AI, there is a specific context. When you say secure AI, what we mean by that is we are talking about techniques which concern the protection of AI algorithms. As I said before, these algorithms are software artifacts, and they can be located anywhere in the ecosystem, starting on server, the front end to mobile phones, and so on and so forth. So we need to secure these because of intellectual property reasons, patent properties, and copyright issues, and so on and so forth. And then we have to also worry about privacy preserving aspects of AI, which is basically those techniques which are used to protect input and output data, where we are talking about privacy of users and patients. Okay, so in terms of regulation usually talks about privacy of input and output data, and security of AI is a more of a concern of vendors and algorithm developers and technology companies. But however, for end-to-end solution, both are equally important. Another new aspect of this is this ecosystem is what we call as federated machine learning. Federated machine learning is a subset of distributed systems and distributed networks, which is a very mature subject. But in the context of machine learning and AI, in this case, the systems rely on distributing the algorithm to an area where the data is residing, instead of the data residing to the algorithm, coming to the algorithm. So if I were a service provider, AI service provider, instead of data coming to me because of the various problems of regulation and other cultural problems, I would give my I would give my algorithms to the user. Okay. So residing of the algorithms to the user is basically federated machine learning. So I'll explain, how this can be accomplished. Is that I will not give my algorithm in an unencrypted form, because that has a lot of intellectual property embedded into it. So I would use some kind of encryption and give an encrypted version of my algorithm to the end user. End user inputs his encrypted data, and the output of that, which is also encrypted, can be transferred into a central location, and where it can be decrypted in a very constrained manner for further processing. Okay, there are many different versions of this, and we'll discuss about few of them. Second aspect of this privacy is called differential privacy, which is a comparatively a newer concept. It came into being in somewhere in 2015. And the mathematics behind it is pretty old, but then it was implemented in a differential privacy ecosystem somewhere in 2015 in Stanford University. And the idea was to, what if we can make some obfuscation in the data? What if I add some noise in the data? Why do I do that? To fool an adversary. Okay. So basically, intentional modification or perturbation of data set, while retaining the ability to derive information out of it in a statistical manner, in a statistical analysis. Okay, it's called differential privacy. So as long as I have a very well-defined scope, also known as privacy budget, I can introduce some noise into the data, okay, and fool an adversary by giving the adversary incorrect information or no information at all. Okay. But differential privacy can also be used on data. It can also be used on algorithms. Okay. But it is a very mathematically bound problem, and it works well if you have a very well defined scope of statistical analysis, and it requires a little bit of statistics to be able to design differential privacy algorithms, and we'll discuss a little bit about it. Now, one way of encrypting data which is already encrypted and performing any computation on encrypted data, there's a very well-known technique called homomorphic encryption. I'm sure most of you or all of you are aware of this mechanism of homomorphic encryption, and it is being used in a very limited way in AI systems, but it is nevertheless one aspect of security in AI. And another very interesting concept, which has been around in theory for quite some time, is multi-party secure competition or multi-party security, which is nothing but a collection of techniques and protocols, in which you distribute a key to multiple parties, 2 or more parties, and they split the data in such a way that they can perform joint computation, okay, so that no single party can gain any knowledge, complete knowledge out of that computation, but they can gain or they can get meaningful information or computation result based on consensus. Only if all the parties come together, they'll be able to make some sense out of it. Otherwise, now these techniques of split keys and multiple group keys and all that have been around for quite some time, almost at least 10-15 years. And but there have been very few implementations of those schemes because many of those schemes do not align with the present laws of the land. And especially, I remember somebody tried to implement a multi-key encryption a while ago when I was in CDAC, and then it was rejected because the IT Act and the laws do not permit that, because our CA authority is based on public key infrastructure, and there is no way we can use a multiple key kind of infrastructure in India as of today. Okay. But you could use this system in a private ecosystem. I'll just show you a typical medical image, which is used in many of these AI systems. And I talked a little bit about diabetic retinopathy because this is an area in which I've been working for 2 to 3 years. Diabetic retinopathy is a very special condition condition found within India, in which people are not even aware that they have this condition. And we've been working on this problem for some time to figure out if we can solve this problem of detecting diabetic retinopathy in rural areas, because this is an area where people do not have access to any good medical service, and because it is left untreated for quite some time, many people actually lose their vision or completely lose their sight. So as many as 30 crore people of our population have this condition, as per some surveys. So we've been working on this area. So let's say we have an IoT device or a camera device or maybe a smart camera, which is equipped with a fundus photographic camera, which can capture retina images in let's say in a village, and these images are transferred to a central site to cloud infrastructure, and then we run our inference engine on top of that, and we classify images into 5 classes, starting from no diabetic retinopathy to all the way to proliferative retinopathy, where a user will have to go to a hospital to get some treatment, surgery done. So anyway, this is one area where images are taken, and issues about privacy and security are many in this. Now, as far as an AI system is concerned, such images are we train a network, neural network called convolution neural network with thousands of such images. Many of these images are available in public domain, and there are many of them which are available through eye hospitals and hospitals across the country. So we use those images and run them through various architectures of CNN. Okay. Now, why am I showing this diagram of CNN is because there's something relevant when it comes to security in this. So if you look at this network here, this architecture, it has multiple layers. Starting from you have an input layer where this input layer is nothing but the image itself. We have this image. Then this image is fed into a layer, a neural network layer, which is called the convolution layer. And then there's some kind of a kernel which is run through it. And then after that kernel is run through it, we have an activation function. The idea of an activation function is to introduce, or rather to take advantage of the non-linearities in these inputs. Because a neural network or any version of neural network includes convolution neural network is nothing but a function, a non-linear function which maps input A to input B with a vector space input of vector space A to an output of vector space B. Any mapping between these two is a function, is a mathematical function, and a neural network actually acts as a nonlinear function. Okay. So we have these multiple layers, and every layer has a activation function. So we have input layer with convolution, followed by activation function. Then we pool those layers and then again convolve it. Convolution is a mathematical function, something like correlation, little difference. And again activation, again pooling, and then flattening it, and then again feeding it back into a fully connected layer, and then finally we have activation function, and then it gives you the output, which is basically nothing but a probability distribution, which maps the input to the output, and then that is run into some kind of a loss function, another cross entropy loss function and all that. And then the idea is that we do a back propagation on this in such a way that the objective is to minimize that loss function. So we do a back propagation, and while doing back propagation, all the weights in each layer are updated. Then the whole computation is done again, known as one epoch. And then again you calculate the cost function, and then it goes on and on till you reach some kind of a threshold and say that, if I reach this minimum of this 0.01 or 0.02 or whatever number, I stop it here because it's not going to get any better after that. So at that point, we have a decent input to output kind of a mapping. So if I give an image of, let's say, a dog, it will tell me with 95, for example, 95% probability that's a dog, and so on and so forth. So the idea behind this, I'm showing you this, is because these activation functions are the ones which require a lot of approximations when we come to homomorphic encryption. Okay, we'll discuss it in a little while. So these are some of the activation functions which are used in CNNs. The most popular ones are on the left-hand side: sigmoid, tan-H, and ReLU, and then you have leaky ReLU and max out and ELU. But most of the time, since 2015 or 16, ReLU functions, activation functions, have been very common. And the idea is that all these functions should be differentiable. If a function is not differentiable, then it will not be able to create any nonlinearity. So as long as the function is differentiable, we have these three functions which are used. One of the most popular is ReLU, and I'll show you how a ReLU function can be approximated for homomorphic encryption. Okay, a typical architecture of secure and private AI. In this case, on the left, I hope the picture is clear. Yes. Yes. We have these actors or these subsystems in the architecture. On the left hand, on the right hand side, you have the algorithm developer or algorithm owner. This would be a service provider who's sitting here, and on the left hand side, you have the users or the end users or patients or the organization which are representing patients, for example, hospitals and clinics and doctors and all. So now, in a ecosystem where I care about security and privacy of both data as well as algorithm, I need my algorithm to be encrypted before I drop it here. So you have this homomorphic encryption of the algorithm. Okay, this takes care of my algorithmic security, and then once I encrypt the algorithm, I drop it on my end system, which is these servers or these machines here. It could be smartphones and things like that. And then the output of this, again, now I have to worry about the privacy of these users. So this is fed into another subsystem which takes care of differential privacy, which I just talked about. It is a statistical and probabilistic mechanism. And then I apply anonymization and pseudonymization. And then this gives me a trusted algorithm. And this algorithm is what is used by the service provider. So we have a complete circle system end to end, where on the right hand side we have the AI developer, and on the left hand side we have the end users. So the data which is the output from here is obfuscated using multiple mechanisms, and then fed into, so that there'll be no way, or at least very few ways, of actually figuring out or getting any meaningful information from this data. So we use homomorphic encryption for encrypting data or encrypting algorithms, and then differential privacy. These are the two main techniques which are employed in AI security and privacy. Okay, so what is differential privacy? So if I have an owner, a data owner, who's sitting here, who owns data, and how do I ensure that this data which is coming from this owner and eventually reaching out to the user who's an application developer is secure, and privacy is maintained throughout the pipeline. So now in this case, when I take the data from the owner to some kind of a storage, you input some kind of a perturbation, which is adding noise to clean data. This noise is some kind of a Gaussian noise, Gaussian white noise, because Gaussian noise is something which can be easily removed after a number of steps are performed on the data. It's a very well-defined bell curve which can be calculated statistically. So I add certain noise to the input data, and then when I give this data to the algorithm owner, I add another set of noise, okay, which is called algorithmic perturbation. So I'm adding noise to the intermediate values in each iteration. So after every iteration, I'm adding little noise. Okay. So there are n number of iterations. I have n number of injections of noise. So this data is inputted to the algorithm, and n number of iterations or epochs. Output of the data is again perturbed. So we're adding noise to the objective loss function of the ML data. So the objective loss function, which I spoke about earlier, is again injected with noise. So we have noise in the input, we have noise in the algorithms, every iteration, and we have noise in the objective loss function. Okay. And this, after calculating all this noise and back propagation, and then doing the complete calculation of weights, which is nothing but the model itself, we get an output. Output also is data. So I have data input, data output, vector space A, vector space B. The output again is added with some noise. Okay. And this output is given to the end user, who will use it in his application, if he's an application developer or a medical practitioner, who's a user, basically a user of the machine learning model. So this adding of noise and the scope of adding this noise, we'll talk a little bit about it, is what will make data obfuscated for any adversary, any middleman attack. Okay. So if I was an adversary and I was looking for a particular individual or particular set of individuals in this data, this system will completely fool me, because there is a error or control error or noise added to every step of the way. Okay. So when I extract a piece of information or data from such a system, I'll not be very sure whether this is the right data for the right user and all. Okay. That's the whole idea of privacy by obfuscation. So a little bit of mathematics behind it, because the whole concept is based on Gaussian noise and control kind of perturbation. Let's say we have two databases, virtual databases, and both of databases are different on only a single record. Okay. So let's say the adversary is interested in a particular record, let's say K. So the probability of him getting any statistic K or any data K should be very close in both data, which means his probability of getting K in database 1 or database 2 or dataset 1 or dataset 2 should be very close. So basically, he does not know whether it will be more useful for him to enter into attack database 1 or dataset 1 or dataset 2. So for all K, the dataset 1 and dataset 2, and the probability and this equation, the probability of K given database 1 and probability of K given database 2, this ratio should be less than some number, which is this number, okay, which is exponential of some cost function or error function. Okay. So if you have a very small value of E, then E to the power exponential of E is equal to 1 in most cases, okay. Which means the smaller this value of difference between this ratio of probability of K given dB1, probability of K given dB2, the smaller it is, the better is your privacy. It's a very well-defined mathematical function. Now, if we have many revelations, if a adversary can continue with this kind of a cycle of trying to find out one particular data set or data point in a data set multiple times, then your E becomes sum of all the E's, which means the more number of revelations you have, the less private the data will become. So there is more probability of that adversary of finding the data which he's looking for, okay, which means after every point T or delta T, we have to reshuffle the data set so that the K which he's looking for, it gets reshuffled, and he starts again with the value of E, which is very small. Let him not accumulate the values of E in such a way that the probability of finding a particular data set for an adversary is high enough. So that is called the scope. Again, so the differential privacy deals with the probability of any static result K given data set DB or data set DS, whatever. Now, in probability, if you're given this data set using Bayes theorem, is it possible that given the probability of K given dB, can somebody find out the probability of dB given K? Okay. So let's say if I know the complete characteristics of a data point, given that, can I figure out where exactly this data point is located in a particular database or data set? Okay. It is possible, but remotely possible. Okay. Highly improbable. So basically what we do is this ratio of probability of K given dB1 and probability of K given dB2, where the difference between dB1 and dB2 is only one static result, should be very small, should be less than this value, which is exponential of some very small value of E, which implies a bound on posterior, which means I'm bound by this posterior. If the value goes up, then my data set is not private. It is not privacy preserving anymore. Okay. And then the same way, if you do this calculation here, I substitute this value for this value here using Bayes theorem, you get something like this. Okay, and this, if I substitute this in this equation, I get this value here, which means this value multiplied by this ratio should be very small. Okay, which means this ratio should be as much as possible equal to 1. Okay, and this should be as small as possible. Okay, if this is small, if this is being 1, my probability of finding K given dB1 or dB2 becomes infinitesimally small. Okay. So if I do repeatedly this differential private observations, if adversary does repeated observations which over a period of time, it is possible to leak non-negligible information. May not be complete information, but non-negligible information. And if I have two statistics, let's say if I have two data points, K1 and K2, and both are differentially private, okay, then this equation becomes e to the power 2e, which means it is becoming exponentially higher, which means the more statistics you release, the larger the E gets and lower the privacy protection. Okay. So this upper bound, the well-defined upper bound of this E value is also called as privacy budget. And you can stop a system or reshuffle the data once you know this privacy budget has been exceeded or it is reached. The moment you reach the privacy budget, you reshuffle the data set. Okay, so that it starts again from a very small value to E, which is the privacy budget. So differential privacy queries are very finite resources and need to be managed carefully and should not exceed the privacy budget from a statistical point of view. Homomorphic encryption is very straightforward. I'm sure everyone knows what it is. Basically, homomorphic encryption allows you to do computation on top of encrypted data. But as far as neural networks are concerned, it can strictly compute perform only two computations. One is addition, the other one is multiplication. So as long as your encryption algorithm is confined to a series of only additions and multiplications, your homomorphic encryption will work fine in neural networks or deep learning networks. In this case, you have an input plain text, and I encrypt the data using some kind of a polynomial. It's a polynomial. So these are the coefficients, these are the variables. So my Q is a variable, P is a variable, and A and X are coefficients, and I use this polynomial equation. So basically what I do is I as long as any algorithm which can be broken down into a polynomial, a low degree polynomial, it will be possible to use homomorphic encryption on that data, with that algorithm. So now let's come back to our problem of encrypting a neural network. And we said neural networks have these very important functions called activation functions, and these activation functions were given by these equations here, sigmoid, this kind of a graph, a tanh, and then ReLU. So let's say if I want to encrypt my CNN or any neural network for that matter, which has activation functions, all I have to do is encrypt these activation functions, which are these functions. And so long as I can convert an activation function into a polynomial of low degree, for example, degree 2 or 3, or even 4, it will be very easy for me to do encryption on, computation on encrypted data. So homomorphic encryption in a neural network can work only in two operations, as I said, addition and multiplication. And all activation functions can be approximated to low degree polynomials. Why low degree polynomials? So that I'm left with only two operations, addition and multiplication. And the accuracy of converting a particular activation function to a polynomial depends on the kind of mathematical function you use. The most commonly used are Taylor series, which allows you to convert any activation function into a Taylor series, but there are many other methods as well. So I'll just take an example here. So in this graph, I'm showing you a ReLU function which I showed you earlier. This is my blue graph is my ReLU function, okay, which is very commonly used in CNNs, especially for imaging. And I'm going to approximate this ReLU function using polynomials, okay, 2 degrees, 3 degrees, 4 degrees, 5, and so on. But the higher I go, the more complex the computation can become. So I would like to keep my polynomials as low as possible, perhaps closer to second order or third order. So if you look at this function here, if I use a second order approximation, second order polynomial to approximate my ReLU function, I get something like this green graph here. Okay. Green graph gives me same output as a ReLU function using a polynomial. If I use a third degree or third order polynomial, I get this orange graph here. Which is actually hidden here in the map. And fourth order will give me this pink graph. Okay. If you see here, the difference between second, third, and fourth is not much. I'm getting pretty good approximation with second order polynomial. Okay. So if I could convert using some mechanism an activation function into a second order polynomial, I can perform homomorphic encryption on top. So there are some implementations which we have used in our work. The most commonly used is Krypton, called Krypton from Facebook, and CryptoDL, which is also very commonly used in academia as well as research institutions. Then you have DeepSecure and SecureML and CryptoNet. These all implementations are used for encrypting and differential privacy of AI. And I have personally been using Krypton for quite some time using Facebook. The reason being that this particular framework is based on PyTorch, which is again an implementation of Facebook, and both of them are open source, very easy to work and experiment with different algorithms. So I'll stop here and wait for any questions.
Thank you, Dr. Ji. It's a wonderful session on the privacy and the AI.
Thank you.
Yeah. So we have a couple of questions lined up here. So in interest of time, I'll be putting few of them.
Yeah.
Okay. So very first question is, how will the problem of data poisoning be solved? The example is lot of fake review exists in the e-commerce site just to promote a certain specific product. And similarly, if the hacker want to fail the AI algorithm, then the hacker would poison the data collected so as the change in the outcome of the analysis.
So you're saying that how do we protect the data points?
Yes.
see, today in today's environment, especially in Indian context, since we do not have any strict laws on data privacy, many of our e-commerce sites which are located in India today may not be following all these procedures for security and privacy. Now, security is taken care of in many ways, in the sense, you have very strong encryption today. So you have data at rest, which is secure, data in motion, which is secure. Okay. So I don't think people have to worry about data being stolen while in transit from A to B, because we have very strong VPNs and algorithms and encryption techniques. Now the problem is most of this data is stolen when it is at rest. Okay. And when data is at rest, especially when it is at rest in a AI ecosystem, it is very vulnerable to such attacks. And the only way to prevent such attacks, as I mentioned, is to obfuscate the data. So that you are basically misleading the adversary into a set of data which is not relevant to him. Okay. So he may still steal it. He may still steal it, but he'll be stealing irrelevant data. Okay. So to answer your question, it may not be possible today to prevent all kind of stealing, because we have a lot of leakages in our e-commerce. But it is very possible using these mechanisms to prevent an adversary from stealing targeted data. So he may steal 10,000 names, but it will be random names. He will not be able to, for example, look for a particular name and steal that particular name. That is possibly very difficult today using these mechanisms. But overall, I will say that our data is not very secure when it is at rest.
Okay, thank you. The next question here is how AI can be useful in detecting and removing a malware in the system.
Malware.
Yeah.
Yeah. Well, there are certain companies which are working on adaptive algorithms. They're called adaptive algorithms. And basically, most malware is signature-based malwares. If they are signature-based malware, and the signature is not known, for example, then these algorithms actually can detect a particular signature based on adaptive system theory, which is a very well-known theory in signal processing as well as control systems, which can actually track the behavior of a particular malware. And based on the behavior of the malware, it can be identified. And once it is identified, it can be dealt with. I mean, it can be removed and stopped. Yeah, today it is possible to do that.
Okay, thank you. So in interest of time, I'm not keeping some of the questions here. So thank you, Dr. Zia, for a wonderful session on the privacy with the AI. Thank you.
Thank you very much. Thank you.
Yeah. Thanks everyone for joining us for today's webinar. And we have the exciting sessions and panel discussion tomorrow on the day 2 of the event. So please join us for it. Thank you again.
Thank you, everyone.